Kia ora everyone, and welcome back to the IA Max channel. Ahmed Mohi here. In this video, I'll talk about the Azure Network Load Balancer, what it is, and how to create one. So let's dive in. Before starting to talk about Microsoft Azure Network Load Balancer, let's talk about how did a user connect to your application running on top of your Azure virtual machine. So what happens normally is that you would have an Azure virtual machine where you are running your application on top of. That Azure virtual machine will have a public IP address, and users will access this virtual machine over the internet. The issue with this setup is that if this machine faces any type of error that would cause the machine to fail, you would have a total outage for your application, and that would translate to revenue loss. And the other problem also is that if you gain a sudden popularity, a lot of traffic will be hitting your application, causing putting your virtual machine on a lot of demand, and it will not be able to keep up with this load, and again your application will fail, and also causing an outage to your application. Enter the Azure Network Load Balancer. So in this setup, what will happen is you would, instead of having one virtual machine, you would have a group of virtual machines in what is called a Backend Pool. All those virtual machines are running a replica of your application, and all those virtual machines in each one of those virtual machines are able to provide services to your users or to your customers. Before those machines, in front of them, you would have what is called the Azure Network Load Balancer. It's a layer 4 network load balancer, layer 4 on the OSI model, on the networking OSI model, and that means it is forwarding traffic based on source IP, destination IP, and then source port, destination port, and what type of protocol, whether it's a TCP, UDP, and so on. So this is the Azure Load Balancer. This load balancer would be distributing traffic equally between your machines in the backend pool. The other piece of the Azure Network Load Balancer is what is called the Frontend IP Address. This is the public IP address that you gave your one virtual machine before using the Azure Network Load Balancer. This is the same IP address that your user or customers would use to access your application. The last piece in the Azure Network Load Balancer is what is called the Health Probe. The Health Probe is a continuous message that the Network Load Balancer sends to your machines in the backend pool to make sure that they are healthy and are capable of providing services to your customers or users. If one of the virtual machines fails the test of the Health Probe, it is considered a failed machine and is removed from the backend pool, and traffic will only be forwarded to your healthy virtual machines. There are two types of Health Probe supported by the Azure Network Load Balancer. We've got the first type is called a TCP Probe. The TCP Probe is a TCP message that is sent to your virtual machine to establish a session with the virtual machine. If the session is established, then the virtual machine is considered healthy. If the session is rejected by the virtual machine, which means that the virtual machine is actually not listening to the TCP port that your application is using, the machine is considered a failed machine, and then it's removed from the backend pool. The other health probe is called the HTTP or the HTTPS probe. This is an HTTP message that is sent to your virtual machine. And for the machine to succeed that test, it would have to return a message of HTTP 200, which means OK. Any other HTTP message that the load balancer will receive from your virtual machine would consider the VM as failed, and it would also be removed from the backend pool. So what are the problems that the Azure Network Load Balancer has actually solved? The first problem that the Azure Network Load Balancer solved is the single machine outage. So as you recall in our first example, without using the Azure Network Load Balancer, we had only one machine. If that machine fails, that's it. That's the end of the application. You have an outage on your hand. But with the introduction of the backend pool, you have a group of virtual machines that all could serve your users. And if one of the virtual machines fails, it's not a problem because you still have other healthy machines in the backend pool that would provide services to your users and customers, and you have avoided an outage for your application. The other problem that the Azure Network Load Balancer has solved is the heavy load of traffic. So again, if you had a sudden popularity and then a lot of traffic is hitting your application or your website, the Azure Network Load Balancer would make sure to equally distribute traffic between the virtual machines in the backend pool, making sure that no one of the machine would be under a lot of stress, and all your machine will be able to quickly respond back to your to the request of your users and customers, and again avoiding an outage for your application. The final concept that I want to talk about before diving into what are the types of the Azure Network Load Balancer is what is called a VM scale set. So we talked about one of the benefits of using an Azure Network Load Balancer is that it distributes traffic equally between your virtual machines in the backend pool. So what happens if you gain like a spike of traffic, and there's a lot of traffic is hitting your application, and all the machines in the backend pool are not able to cope up. So what normally happens is that you manually add more virtual machines to the backend pool so that the traffic will be distributed between those virtual machines, and again lessening the load and the demand on all those virtual machines. This is all good, though this depends on how fast you act on the sudden increase of traffic, because the process is manual, adding more virtual machines to the backend pool. What Microsoft Azure has provided us with is another thing called a VM scale set. A virtual machine scale set is a group of virtual machines. The number of the virtual machines in this group are increased and decreased automatically based on the demand. So what we'll see in a minute is that we could, when we add virtual machines to our backend pool, we could instead add a virtual machine scale set. So this way, if a sudden traffic hits our application and the load balancer is distributing traffic between VMs in the backend pool, those VMs are actually not just a VM, they are a VM scale set. And if the demand increases, the number of VMs will be increased automatically. If the demand decreases, the number of VMs in this scale set will be decreased automatically, again solving the problem and avoiding an outage to our application. Let's now talk about the types of Azure Network Load Balancer. So we have two types of Network Load Balancer. We have a public load balancer and a private or internal load balancer. A public load balancer is just basically a load balancer with the front-end IP being a public IP address. Then this IP address could be accessed over the internet. And it would be translating those, mapping those IPs, public IPs, and TCP ports to a private IPs of your virtual machines within your virtual network within your Azure subscription. The other type of network load balancer is internal or private load balancer. This internal load balancer would never face the internet, would never have an IP address that could be accessed over the internet. And the only resources that would be able to use this internal load balancer are your internal resources, like machines on your virtual network or machines on premises that would access your Azure subscription over a VPN. And those internal load balancers are normally used to connect your, for example, in here, to connect your web tier virtual machines to database tier SQL servers. These are to provide services to your web virtual machines, things like data processing and so on. The final concept that we'll talk about today in the Azure Network Load Balancer is what is called the session persistence. So by default, the Azure Network Load Balancer would distribute traffic equally between your virtual machines based on a hash calculation called 5-tuple hash that is using the source IP of the traffic, destination IP, source port, destination port, and the protocol. So let's say that the first traffic came from machine 1, so it will have different source IP, different source port, and so on. And based on the hash calculation, the traffic would be sent to virtual machine 1. If the traffic is coming from machine 2, the source IP would be different, source port would be different, and then again using the hash calculation, traffic would be sent to virtual machine 2, and so on and so forth. This is all good if I don't care which virtual machine would provide me service each time. Though in specific cases, I want the user or my customer to always be serviced from the same virtual machine. This is what is called the session persistent. So an example of this is a shopping cart. So I've got a customer who's using my website and they want to buy something, and they're adding those items to the shopping cart. I don't want them that each time they establish a session or that each time they send traffic to my application that they will be serviced from a different virtual machine. I want them to always be serviced from the same virtual machine, because this virtual machine will be keeping those information like what items he's got in his shopping cart. And another example, if you are uploading a file or if you are using a remote desktop protocol, so you want to always all your traffic to always be sent to the same virtual machine. So to do so, we would use what is called a network load balancer distribution modes. The distribution modes by default is none. So none means Azure Network Load Balancer would use all the five tuples here, source IP, destination IP, and so on, to send traffic toward whatever machine based on the hash calculation. The other method is you would tell Microsoft Azure Network Load Balancer to use the client IP. As in, all traffic that's coming from one user from the same IP address always send this traffic to the same virtual machine. So if I have one user with 10 type of traffic, his traffic will always be hitting virtual machine 1, but the second user will be sent to virtual machine 2, and so on. The other thing is called a client IP and a protocol. This time I want, so if the client is, for example, accessing my application using HTTP, using a web browser, and then when they upload their file, you will use the FTP. So it is okay for him to access my application maybe using a web browser, but when he uploads the file, his traffic could be sent to another virtual machine. This is where you would use a client IP and protocol. So if the client have more than one session or more than one type of traffic, based on the type of traffic, based on protocol the client is using, he will be serviced by a different virtual machine. So now that we are ready, let's jump in on the Azure portal and create our Azure Network Load Balancer. So now that we are on the Azure portal, let's understand a bit our scenario. So on the virtual machines, we've got two virtual machines. They are called WebVM1 and WebVM2. Those virtual machines are hosting our application, and we want to create an Azure Network Load Balancer that would distribute traffic equally on those web virtual machines, and then we'll also access them using the front-end IP address. So let's do that. So to do that, let's go back to the Azure portal. And then from there in the search bar, let's search for Load Balancer. Let's pick Load Balancer from the search results, and then let's create a new one. To create a new network load balancer, let's click on the Create. Let's pick the subscription, and let's pick which resource group it is going to be part of, and then let's give it a name. we'll leave the region as is, and then it's asking us for this queue here. So we've got basic and we've got standard. Standard would give us more advanced features, things like being able to do load balance or distribute traffic over HTTPS and more advanced feature. But for our example, basic would suffice. And then next, it's asking us for the type of the load balancer, whether it's a public or internal one. We know that we need our users and customers to access our application over the internet, so we need a public IP address, so we'll leave it to public. And the tier we'll talk about here in a future video. We'll leave it to the default one, which is regional for now. Next, we need to create the front-end IP address of the load balancer. So to do so, let's click on the plus add front-end IP. And let's give it a name. We'll pick IPv4, and then we don't have a public IP address as of now, so we'll create a new one. Public IP, and we want the assignment to be static, as in we want a static IP address so that it will be fixed. So with the dynamic one, we'll get a new IP address each time, and we want our users to access our application using the same IP address. So we'll keep it to static, and then let's click on add. Next, we need to create the backend pool. So let's click the add a backend pool. So let's give it a name. And then let's pick the virtual network. And then finally, in here, we are going to decide what type of resources we'll have in our backend pool. As we said, we could either pick virtual machines or we could pick virtual machine skill set. So we'll pick virtual machine for our example today. And then this is the version of the IP address of the backend pool. And then let's click on add to add our VMs or web VMs that we have today. And then let's click on add. So now that we created the front-end IP, we created the backend pool. Next, we need to create the inbound rule. The inbound rule is that it means like how are we going to load, based on what we are going to load balance traffic. So do we have a TCP application, an HTTP application? What is the protocol that our users will use to access our application running on top of our virtual machines? So to add a load balancing rule, let's click on add a load balancing rule. Let's give it a name. Let's pick the IP address, which is IPv4. And then let's pick the front IP. We'll pick the front IP address that we created a minute ago. And then we'll pick the backend pool. And then next we'll specify whether it's a TCP or a UDP protocol that our users will use to access our application. So our users will use HTTP, which is TCP, TCP port 80. So we'll pick TCP and we'll put the port as 80 for the front end, and also for the backend pool, it's again 80. We could using this configuration, we could actually map the front end TCP port to a different backend TCP port. But in our case today, we are making both the front end TCP port and the backend as 80. And then next we need to specify or create a health probe. So we don't have a health probe as of now, so let's create a new one. So let's first give it a name. Let's specify the protocol that we will use to measure the health of our virtual machines. And in our cases today, it's TCP. We could pick HTTP and it still work. For the interval, it means like how long it will wait before sending another Health Probe. So the default here is 5 seconds. And for the unhealthy threshold is that what happens, like how many consecutive failures it is okay before it actually consider the machine as a failed machine. So the default here is 2. So after 2 consecutive health probe failures, the virtual machine is considered failed and it's removed from the backend pool. So let's click on OK. Now we will configure the session persistence. So as we said before, the default is none, which means that the load balancer will use the whole 5 tuple, the source IP, the client IP, the destination IP, source protocol, and so on. We could either use client IP, which means that always send traffic from a specific IP address of a client to the same virtual machine, or send traffic based on the client IP plus the protocol that the client is using. We'll leave it to none for our case today. And the idle timeout here, it's about the TCP session. So when you establish a TCP session, if there is no activity for 4 minutes, the session is considered idle and then it's killed. So you could configure this over here. And as for the floating IP, it's for advanced scenarios. We'll not talk about it in this video today. So our load balancing rule is now ready. So let's click on Add. For our scenario today, we don't have any netting rules, and also we don't have any outbound rules. So our network load balancer is actually ready for us to create. So let's click on Review and Create. So our load balancer is ready. So let's click on Create. Our network load balancer is now ready. So let's click on Go to Resource. And let's find out the public IP address for the front-end IP. So let's click on the front-end IP configuration. And then again, let's click on the front-end IP. We want to find out what's the public IP address for that we will use to access our application. So in our case today, this is the public IP. So let's copy this IP and then let's try to access our application. So let's access our application here. Let's open up a new tab and then paste our application and access it. So as you can see here, we are able to access our application, and the patient portal is telling us that our application is actually served by WebVM1. So the Azure Network Load Balancer used the hashing 5-tuple hash mechanism and decided to send my traffic to the first virtual machine. So what I'll do here, I'll try to force refresh the portal by clicking Ctrl F5. Hopefully my traffic will be sent to the next virtual machine. So as you can see here, my traffic is now being serviced by the second virtual machine. We didn't change the public IP address, it's the same, which means that the Azure Network Load Balancer is working and my traffic is being distributed first to the first virtual machine, WebVM1, and then it was sent to the second virtual machine. So what we'll do now is that we will go and shut down the second virtual machine and then refresh our application again, and that would not cause an outage, because then the Azure Network Load Balancer would forward traffic to the other healthy virtual machine, which is WebVM1. So let's do that. So we'll go back here, we'll go to Home, to Virtual Machines, and then we'll go to WebVM2, and then we'll stop the virtual machine. It'll take a second for it to stop. And then after that, we'll hit refresh, and hopefully we'll be served by the first virtual machine. As you could see here, our second virtual machine has now stopped. So let's go back to our portal, and now we'll hit refresh, and hopefully we'll be serviced by the first virtual machine. So let's do that. And as you can see, the Azure Network Load Balancer has actually detected that the second virtual machine is no longer healthy. It's no longer replying back to the health probe of TCP session. So it removed it from the backend pool, and now our traffic is being serviced by the first virtual machine, the other healthy one, and we have avoided an outage. I hope you found this video useful, and if you have any comments or questions about the Azure Network Load Balancer, please leave them in the comments below, and as always, stay strong. See ya.